Okay, so I want to talk about parsing and writing binary data in Ruby, but before I do that, I just have to say something. So you see this t-shirt, and I think most of you actually, or many of you actually like this t-shirt design very much. We actually have something like 5 or 6 t-shirts left for sale. Please find the guy in the green senior developer. He's over there. And I wanted to do one quick other thing. I'm probably wasting my time on this, but anyway. My dear colleague, Christoph Sassenberg, by the name of DevSprite on Twitter, actually designed this. And since I think this is recorded on video, please give him a warm applause for that so that he can look at this, because he can't be here. Thank you. Thank you so much, Christoph. So now, how many of you know what this is? Okay, a few hands. This is actually one computer program I spent most of the 90s in. This is a ProTracker, a very ancient music program. And it uses a file format that's called mod file, and it kind of survived the times, and you can still find a lot of mods on the internet and play them with various types of software. But obviously it's a binary format, and the description looks a bit like this. So, well, I don't want you to read it, but it's pretty extensive. So, what is a mod file? What does it contain? So you have instrument metadata. Instruments and ProTracker are done. You basically play back samples, so audio, recorded audio, and so it's basically an array of structs which kind of converts into an array of hashes in Ruby quite naturally. And then you have the sample data, which is basically an array of blobs. Pattern data, which is an array of an array of structs. And sequence data, which is basically just an array of integers, which kind of points to the actual patterns. So the simple approach would be just write serializers, deserializers, just procedurally convert that to Ruby objects. And you have quite a range of different data types in a ProTracker module. So you have something like 8-bit signed binary blobs, the samples. You have unsigned integers, 8-bit, so that would be bytes. You have unsigned integers, 16 bits. And then you suddenly have to worry about endianness of these values. So is it big endian, little endian? And yeah, of course, because it's ancient and C-based, you have zero-terminated padded strings in there. And then you have crazy stuff like, signed integers, just, half a byte. And that's me. So you also have things like this. And there, it kind of gets interesting. We have, several bytes, 3 in this case, and it's kind of, interleaved, the values are interleaved, and if you code this down just procedurally, you end up with a pretty mess. I'm pretty sure you could do it quite nicely, object-oriented, whatever. But I kind of want to do it declarative or declarative. Sorry. So there's a gem called bin data. Anyone knows this in here? I kind of expected that. And you can just declare your data like this, and it's pretty cool. Of course, you have to say, you have to deal with endianness, and you can just default to something here. And then you can define, well, first of all, you just have this bin data record, and you just build your classes on that, and then you have the endianness, and then you have something like trim padding. If there's a string, it just strips down the extra bytes after the 0 bytes. Then you have something like, you can define subtypes, which are also bin data record, and you can do an array of them, and you can give them a length. And also you can do, some things in the ProTracker module are quite complicated. You have things like a pattern, a list of patterns, but the actual length of the patterns is not, it's not like you can just read it and then at some point stop, because you have to know how many of those you actually have to read beforehand. And so there's this lambda syntax where it kind of defers the actual thing. Yeah. And This is what I built. Thank you very much.